Okay, 9.1 exponential growth. You guys are going to have to bear with me because I am sick, so I'm going to try and make this video fast. If the variable is not in the exponent, then it is not an exponential function. Okay, so this is an exponential function. All right, and I'm going to change some things here. So A, that is your y-intercept, okay, or your initial value. I'm going to actually change B to R, okay, and that's going to be called your ratio. Okay, some conditions: A cannot equal 0, and the ratio R is a positive number other than 1. Okay, so R will never be negative. All right, so let's look at these examples. We're looking for the ones that look similar to this up here, the y equals a times r to the x power. Okay, so notice that your variable, or x, is in the exponent. So why don't you walk yourself through these and decide if it's an exponent, yes or no, and then what would your initial value or y-intercept be, and then what would your ratio be. Okay, so hopefully this is what your answers look like. First one, yes, since there's not two numbers present right here, it's just the number 2, then it's understood that A is 1, and then your ratio is 2. The second one is no, because your variable is at the bottom, while the exponent is an actual number and not the variable, so therefore it's not. Number 3, I guess, is -3 is your initial value, and 2.6 is your ratio. It can be fraction. It doesn't have to be a whole number. All right. Number 4 is 10 is your y-intercept, or your a value, and then your ratio is actually 1/6, because remember, negative exponent tells you to flip your base, so it actually becomes 10 to the 1/6. 10 times 1/6 to the x power. Okay, and then number 5, I think 2, 4, 5, yeah, is no, because E is actually a number. It's like pi. I don't remember the exact value. It's like 2 point something. So therefore that, I'm going to put like so you guys don't assume that it is pi. So therefore this is not an exponential function. Okay. All right. So let's do some examples. Linear versus exponential. So if we have two functions here, f of x equals, 2x plus, 2. And then we have f of x, which is 2 times 2 to the x power. Okay, so let's kind of look at why these are different. So if we graph the first one, your y-intercept is 2. And then we can find a value. If we choose any x value, we can find the y value. So then this would be 4, right? So when x is 1, y is 4. Okay, and then I can even choose a value previous to the y-intercept. So for example, I could use -1. And once again, I'm just making up these points. All right. So in -1, it'd be 0. So I'm not going to be able to draw a straight line. Whoops. That's your linear. Okay, now let's look at how it varies with our exponential. So I'm going to use the same values that I used on the linear function. So if I have to the first power, 2 to the first power is just 2. And then 2 times 2 is equal to 4. So when x is 1, y is 4. And then this is your initial value. Sorry, I should have done that first. And then if x is -1, well, that's 2 times the 1/2 power to the, times 1/2 to the first power, which would just equal 2 over 2, which equals 1. So when x is -1, y is 1. All right. And then if you keep doing that, it actually starts to curve more like, or let me see if I can do it. More like that, okay? So that's an exponential function. And the key thing here is exponent. So remember with the linear function, we were plugging it in to here and multiplying it, but this time with an exponential function, your x value is being placed as the exponent. All right. So, exponential growth functions. If r is greater than 1, then the graph will grow away from the asymptote as you move left to right. So the the x-axis, where y is equal to 0, is called an asymptote. Okay. Ooh. An asymptote is an imaginary line that a graph approaches more and more, but never crosses. Okay. So here we have a function. Let me just make one up. F of x equals 2 times. I'm just trying to come up with things. I guess we'll just use the same one from the top. Okay. 2 times 2 to the x power. So when we went here to 2, and then 1 was at 4. I have a dot there. And then when we were at -1, we were at +1. Yeah. Okay. And so this is how our graph looked. And so as you get closer to the x-axis, the numbers start getting smaller, but it never ever crosses it. So therefore your domain would be all real numbers. Okay, but your range would only be from, we'll say from 0, never equals 0, and then to infinity. All right, because this line keeps extending further up. Okay, so let's look at the next page. So now we're just looking more at which ones are exponential growth and which ones are exponential decay. So if you're reading from left to right, so I'll just write that in here. I don't know why, but you guys always want to go the opposite way. You want to read from right to left, but you're not supposed to do that. That's not how you read. You always read from left to right. So if you read from left to right, if the line gets further from the x-axis, I guess I'll write this down for you. If the line gets further okay, so if the line gets further from the x-axis, then it's growth, all right? So if we're looking from left to right, this line is actually getting closer to the x-axis, so this is decaying. This one is a decay, okay? On this one, if we look left to right, you notice how the line keeps branching further down and it's moving away from the x-axis. That one is considered growth. All right. Now, this one, they have their asymptote further down. It's right here. So pretend like that's the x-axis. So it's not necessarily that it's getting further away from just the x-axis, it's getting further away from its asymptote, okay? But we're really only going to have an asymptote of 0, so it's not something that you really have to worry about your graph being shifted as much, but it's good you need to understand that it's growing away from the asymptote. Okay, so for example, this one right here, if this is where its asymptote is, it's getting further from its asymptote, but it's moving away. So then that one's still growth. Okay, and then this one's asymptote is, whoops, I did not mean to use that, is about right there. And so when reading from left to right, it's actually going towards it. So then that's actually decay. All right, so let's graph this exponential function, creates table, and find its domain. So I always find it easier to do about 4 points to like make my table first when it comes to exponential functions than to try to graph it first, okay? So I use a variety of numbers, but I kind of know where to start, and you guys struggle with that. So let me show you with -2, -1, 0, 1, and 2. Okay, so if this is my x value, I'm going to plug it right in for x. So I'm going to zoom in super close. Okay, so if this is your function, and I use -2, well then I have 1/2 times 2 to the -2 power. Negative exponent tells me to do the reciprocal of the base. Alright, and then do my exponent. And then multiply those, okay? So then, oh, sorry. I obviously can't do math. Okay, so then that would be my answer. So when x was -2, y is 1/8. Okay. Let's do -1 now. So 1/2 times 2 to the -1. So now it's just 1/2 times 1/2, which equals 1/4. All right, 0. 1/2 times 2 to the 0 power. Remember, anything to the 0 power is 1, guys. All right, and so then it's just 1/2, which is obvious too, because this number right here represents your y-intercept. And so if x is 0, then y is that answer right there. Okay, we can do 1/2 times 2 to the 1 power, which would just be 1/2 times 2, which is 2 over 2, which equals 1. And then we have 1/2 times 2 to the second power, which is 1/2 times 4, which is just 2. Okay. So I think branching out and getting 5 different numbers is going to make it easy for you. I think 0 should be your center. You should choose 2 on top, 2 on bottom. Okay. And then it'll help you graph. So obviously I'm not going to graph with either of those two. I'm just going to start at 0 and go forward. So 0, 1/2. Whoops. Okay. 1, 1. And then 2, 2. Okay. And even if I put in 3, 1/2 times 2 to the third power, 1/2 times 8, that would equal 4. So then even if I went to 3, 1, 2, 3, 4. Okay. And we can kind of see it curving. So my domain would still be all real numbers. Okay. It's probably always going to be that, for us at least. And then my range would be anything greater than 0, right? Because as long as y is greater than 0, we're fine because we're above the axis. I know, I'm talking too much. This video is already 15 minutes long. Okay. For exponential functions that are in the form of a times b to the x power, the graph will go through the point 0a and 1, oh crud, hold on, and 1a times b. Okay, sorry. I had to really think about that. I forgot for a second. Okay, so those are always given points. If you just remember that, it'd be nice and easy for you. All right, so why don't you try those two examples on your own and then check your answers with mine. Okay, so this is hopefully what you got. The one thing I just want to point out is number 3. If you notice here that our range now is when f of x is less than 0. Okay, so we're no longer above. This is still showing growth. Okay, because if this is our asymptote, we are reading from left to right. We are moving away from it. Okay. All right. Leave any questions or comments you have at the end.